Hey guys, David here and welcome to another video. Just last week I released a video about how I built a DIY macro keyboard, and I just gonna give you an overview, show you what I did, but in this video I want to go much deeper and explain in more detail, more generally as well, how you can use an Arduino to build a keyboard. Many of you might be wanting to do a similar project, but not the exact same way. So I'll try to explain it as general as possible and give you all the necessary knowledge and tools for you to successfully also make a DIY keyboard project. So to start off, I want to give a big thanks to PCBWay, who are sponsoring this project and also this video. You can check them out at the link below. They have a whole bunch of great PCB products. You can get your own custom PCBs made. A set of 10, like the ones I used in the video, only cost $5, which is an extremely great price and allows you to, well, get your own PCBs made for your project without breaking the bank. I'll talk more about them a bit later in the video. So let's first start off with the electronics, and the software I use to design my electronics is Eagle by Autodesk. They're the same ones that make Fusion 360, and it's a great piece of software. Now, if you can't get the education license, it does cost some money, but there's enough ways to kind of get around it. Otherwise, there are also many other PCB making software out there. The reason why I like Eagle though is just because it integrates very well with Fusion 360. Once I'm done making the PCB design, I can directly send it to Fusion, and it takes all the 3D models that are usually already pre-made for the components that I'm using in there, and then updates the model in Fusion 360. Then I can model my enclosure around it, and I know that it will fit perfectly without needing to do a lot of trial and error. And also, if I update anything in the PCB later, then I can just very simply click the update button and my 3D model will also be updated in Fusion. But there are of course other ways around that as well. So let's take a look at the schematic for this project. Here, this here is the Arduino. I just used these two pin headers here to represent the Arduino. I labeled the pins like they are labeled on the Arduino. By the way, speaking of Arduinos, not all Arduinos will work. It has to be one of the Arduinos that is using the ATmega32U4 processor, as that one has the USB controller built into the processor itself, which gives it the possibility to also act as a USB input device for your computer and not only be programmed over USB. Some of the Arduinos that include that processor is the Arduino Leonardo, the Arduino Pro Micro, the Arduino Micro, and some others as well, but these are the most common ones. For example, the Arduino Nano or Arduino Uno do not have that processor and will not work at all with this library and cannot be used as a keyboard input. The one I'm using here is the Arduino Micro. It has plenty of pins for what I need and is nice and small, so I can easily hide it away in my project. I label all the pins here like it's on an Arduino, as I already said, and that's just going to make it more easy to read in different places in the schematic, so I don't have to draw traces everywhere and make it super complicated. Then here, this is the main event and what is basically the so-called almost magic behind it. If you try to hook up every key to a different input of the Arduino, like you might be doing if you have one or two keys, where you just hook it up between the input and ground and then use the input pull-up in the Arduino software, that works great for one or two push buttons. But if you have 10, 20 or 100 push buttons, that would mean you need 10, 20 or 100 pins, and not even an Arduino Mega would have that many pins. So instead what we're doing is we're creating a matrix. It's basically a grid array for all the keys. Now it doesn't really matter which way the keys are laid out on your keyboard. In the end, if you for example have a long row, you can still wire them up electronically in a matrix, and you kind of want to have it as close to square as possible, as that's the way you need as few pins as possible. Here I'm going for 4x4 matrix, which is what I used in my design, but in other designs I've also had larger matrices, such as like 7x8 or something like that. Now, to wrap your head around how this matrix works, I'll try to visualize it as much as possible. These pins here on the side, they are kind of my output pins. And when I actually want to read out the key matrix, I'll start out with one of them. First, to begin with, all the pins are set to high. These input pins up here, they have the input pull-up activated, meaning that they are logically high as long as nothing is pulling them to ground. As if you then connect one of these pins to ground through a switch or something, then it will read low, and as soon as you release it, it will automatically read high again. And then these pins here are in the setup are also all set to high. So if we were to read out these pins in the beginning, they would all read high, and that's what I want. Then when I go to read out one of the rows, this matrix is read out in rows after each other, and then I set one of these rows, let's say this row here, I set that one low. And then if I just set that one low, nothing is going to happen because all the switches are deactivated. If one of these switches, however, is pushed, let's say that one, this low signal will go through here and set this D6 here to low. And so what I'm doing is after I set this pin low, I read out after it all these pins, and if any of them are low, I know that the switch that this one is connected to has been pressed. And then after that I set this pin high again and set this one low, and then read out this row. Now you might think that what if I press the switch really quickly while it's reading out another line, but the code goes through this process so quickly, it only takes a few microseconds, that even if you super quickly press the key, it will still like have read the key many times, so that's not an issue whatsoever. Now if I were to just have the keys hooked up in the matrix like that, it works fine as long as one key only is pressed at the same time. But as soon as you have more than one key pressed, it gets really wonky. Let me illustrate. For example, if I have set this row here low and this key here is pressed, then this entire thing here also becomes low. But let's say this switch here is also pressed, then it can go through here, and this one all of a sudden becomes low as well, although it's also set high. And if, for example, I don't know, the switch over here was also pressed, and then this one would also read out low, and it would become all kinds of like weird artifacts that would be a pain to decode in software. That's what these diodes are here to solve. They allow the low signal to go through that way, but even if that key is pressed here, the low signal does not go through that way because the diode is blocking it. And that's how you can get around those ghosting issues and essentially press as many keys at the same time as you want and still be able to read out all of them properly. Now it of course doesn't matter if the diode is before or after the switch. You just have to make sure that the negative side to the diode is going to the outputs, and the positive side of the diode is going to the inputs. Now if you wanted more keys, you can just take all of these components and like add another row at the bottom and basically expand this matrix as far as you want. And although I have 16 keys here, I only need 8 inputs or outputs of the Arduino. And if you go to 5x5, you have 24 keys but only need 10. So the larger you go, the more keys you get per input. Now that's it basically for the electronics of the key switches themselves. While we are here in the electronics program, I want to also quickly show you the LEDs I'm using. And while you could try and also build a matrix with RGB LEDs, there really is no reason to. LEDs are available with a lot of electronics already integrated to them. Those WS2812 LEDs, also called NeoPixels. They are such a great product that it's not even all that expensive. You can get them already in LED strips, or you can get them as individual LEDs. What they allow you to do is, although they have 4 pins, that's not for like RGB and ground, but instead it's the voltage positive, ground, which you just directly hook up, and then they have a data in and a data out. That allows you to daisy chain them together, like the data out of one LED goes to the data in of the next one, and you can chain them together like that, just like an LED strip. And then the very first data in is connected to any one pin of your Arduino. You just have to put a 360 ohm resistor in between. That's just to limit the current and stuff. But then you can use the NeoPixel library on Arduino and basically say, I want the 5th LED in the row to be green, the 3rd one to be blue, and address them in that manner. So you only need one single pin of the Arduino to control basically as many LEDs as you want. And that's really, really convenient. Now, one thing you have to keep in mind is that these LEDs, they have a lot of brightness potential. Like, it's amazing how bright such a small LED can get once you set it to 100% power. But the Arduino has a very limited power budget available that it can pull through the USB port. So if you want to be able to use them at full power, you will have to supply additional power to your Arduino just through an external power supply or through a second USB port or something. But what I'm doing, since I don't need them at full brightness, like 20% brightness maximum is super bright already for a keyboard, so I'm just never setting them like past 20% in software, and that's how I can get away with just using the USB power. And to just kind of, if I change the colors very quickly or turn these LEDs on very quickly, then a lot of power gets drawn very quickly, which might cause some problems because the USB takes a little bit of time to properly give all that power. So I just added some capacitors between positive and ground. Doesn't really matter what size they are, they're just kind of whatever I had lying around, and they're just there to kind of smooth out any extreme current draw and make sure that the Arduino doesn't crash if I suddenly turn on all the LEDs. And with all that those schematics done, I just want to quickly show you how that then looks when I assemble that into a PCB. Now, of course, this is fairly simple. Like, if you did not want LEDs, you could easily wire this up by hand, just have the switches and solder the diode directly to the switch and wire it up to an Arduino. The first keyboard I built, I completely wired up by hand, just to kind of make sure it's working. But it's fairly simple to just make a simple PCB out of it. There are great tutorials online of how to use Eagle or other PCB software, and then you can just quickly design a PCB like that. Once you have the schematic drawn, like all the components are already there, just gonna have to pull them to the right place where you want it. And then once you have your PCB designed, you can then send it off to any PCB manufacturing, or of course manufacture it yourself if you have the necessary equipment. In my case, I'm using PCBWay. I just export the files, send them to them through the online submission. An engineer of theirs takes a look at them, make sure that they're all properly exported and manufacturable. Then they are manufactured and sent to me in a very quick manner. It only takes a couple of days. Thanks to their very, very affordable prices, it's quite easy that even if you for some reason screw something up and it's not working, then it's not the end of the world. You only paid $5 and you can just fix it, either fix it on the board manually or make a second revision of it and get it produced as well. The other feature that is great in Eagle is this button here to sync it with Fusion 360. I can push this design to Fusion 360, and then when I open it up in there, here is my PCB. I did not model any of this inside of Fusion. This is directly what is exported from Eagle. And since the components I am using in Eagle already have 3D models attached to them in the background, all of it directly gets modeled here properly. Like you can see all the key switches that I'm using, these red ones, they don't have textures, but those are the LEDs. You can see the pin headers. I didn't put the Arduino in because the Arduino is not technically like a component in the electronics design. It's just the pin headers. That's why the Arduino itself is not showing up. But you can also see all the diodes and stuff, and that's just super convenient. It even like updates all the silk screen, which is super cool to kind of look at, and it gives you a great like visual representation as well of what you're gonna get. Now, of course, the color here is just the default green, but when ordering your PCB, you can get many different colors, also stuff like black, white, more neutral colors if you don't want a green PCB. After that, I was just very easily able to model all the like enclosure bodies around my electronics design and make sure that it fits perfectly and looks great. And then after printing, like it also in physical world fit perfectly. So that's just a very convenient thing. That basically concludes the physical aspects of building your own keyboard. Now I want to jump over into the code. Now the most important thing is if you want to build a keyboard that gives keyboard inputs, you need the library keyboard. It's available from Arduino directly, and you can just simply import it. If you wanted to make a MIDI keyboard, for example, then you would need the appropriate library for that. Also, if you wanted to like have your keyboard act as mouse input, like mouse clicks, you will also have to import that library additionally. Then for the LEDs and controlling them, it's the Adafruit NeoPixel library. It's one of those libraries where you just look at the example code, you copy it in, and it works perfectly. These here are for the clicking coder that I also added to my design. I haven't talked much about it because it is more specifically to my use case, but I'm also using a click encoder wheel that I just, if you take a look at it here, I just using 3 pins of the Arduino wired up to a pin header, which I then connect my clicking coder to. And for that one, I just also need these 2 libraries, but I won't go into too much detail since that's not the focus of this video. Then here to set up the LED strips, you use this line of code. This here is the name for whatever your strip. You kind of setting it up as an LED strip, although it might be arranged as a grid or whatever. And you just specify how many LEDs you have, which pin they are connected to, and these are just some settings that you have to set for which kind of LEDs they are. Then here I have my Arduino pins that are the inputs. I made an array here to have all these pins in there. That's just going to make the code much nicer. Here I have the outputs. The in count out count is just how many are in there. Like I could have declared that as 4, but this way if I change it, and I could use this code for different things. Then here, this 2-dimensional array is all the characters for what is going to be pressed. Like when the software here realizes, oh, a key has been pressed, I should send the signal. It knows, oh, it is that key of that row and that column, and then it goes to this list here with and says, oh, it's that row, that column, oh, this is the character that he wants me to send, and then sends that. There are different ways that you can program a keyboard to act like a regular keyboard, but what I found most useful is that, like, first you want to, if you press the key down, then you want it to immediately send the first key. But then if you keep holding it down, you don't want it to just spam infinitely many characters. Like, if every time I read out the keys and it was pressed, I would send a character, like even if you just press it down really fast, I would still get like 100 keystrokes, which would be made way too much for your system to handle and make it impossible to type. So I need to kind of filter out some of those. And also, if you like keep holding the key, you at some point want it, after like an initial delay, you want it to start sending more keystrokes. Like if I hold down the G key, like at first there's going to be one, and then it starts spamming more of them. So these arrays here, first the integer is just kind of counting how many like cycles it has run through per key. Like when I start pressing down a key, this number in here starts running up. Every time it goes through, it moves up by 1. And then I have a variable that I check here, for example, long press delay. That's how long I wait after I press it down first until it starts spamming. 350 is the value I chose. So until this value is, like the first time the key is read out as being pushed, it sends the keystroke, and then it starts just adding up in this array here every time it reads it out again. And only after 350 times it starts sending another keystroke. Then this Boolean array here, also two-dimensional array for all the keys. This one is here to basically, if it is already spamming keys, because then the delay for the next key that is sent will be shorter. In the setup here, I am declaring all the outputs as outputs and writing them as high, all the inputs as input, and activating the input pull-up. This is just going to set them logically high whenever nothing is pulling them to ground. For debugging purposes, I'm also establishing a serial connection, but if you were in like the final code, this is not necessary. But what is necessary is to initiate the keyboard library and write keyboard.begin. This is gonna establish a connection between the Arduino and the computer and tell the computer, hey, I'm a keyboard, recognize me as a keyboard. After this line is written, you can start sending keyboard inputs to the computer. I also have the LEDs that first you have to also initiate those, and then you can set the color of them by strip, which is the name we gave the LED strip, .set pixel color. You say which pixel, and then the color as an RGB value. 50-50-50 will be white, but it's not too bright since it goes to 255, so only 50, that's only about 20% power, which is about the maximum I want to go due to power constraints. But you also have to remember is after setting all the pixel colors, you also need to show them on the strip. That's just so that it doesn't like change the color one by one, but you can set all different colors and then show them at the same time. This stuff here is just for the encoder wheel, which I won't go too much into. I already kind of briefly covered how the loop works in the overview video, but it's similar to what I explained when we looked at the electronics before. In the loop here, it is reading out all the rows, all the keys after each other. This for loop here, it basically means that all the keys have been read out once. Then everything in here is repeated 4 times for the 4 rows. If you had more rows, you would repeat that more times. First of all, I'm setting the output low of the row that I am reading out. Then I'm just waiting a couple of microseconds. With delay microseconds, you can wait smaller units than just a millisecond. So 5 microseconds, that's like basically no time at all. But it just kind of makes sure that all the input has gone low properly. It's not rushing ahead. Like 99% of the times it works without this line in there. This is more just kind of a redundancy. And then in here, this is going through each key of that row. So this loop is also repeated 4 times. So I'm going in and have the if statement here. If that input that I'm reading is low, then I have a key pressed. This is a different function that I wrote that I will go over later. So I'm saying the key has been pressed at these locations. The I and the J are the like enumerators for these loops, which also then correspond with the position of the key. And if that is not the case, but the variable key down is not equal to 0, meaning that the key has been pressed for a while but then has been released, so it's not pressed down anymore, but the variable still is not 0, then it will just reset the key, which is just resetting all the variables and setting it back to 0. Then this is repeated 4 times for all the keys in that row, and after that, that row is set high again, and I'm waiting just a little bit of time. I could set this lower, but it's just waiting half a millisecond to make sure that everything equalizes nicely. After that, it's repeated again for the other rows. Now that we have the basic rundown, I want to go more in detail what happens in this function key pressed. What happens when the key is read out as pressed. Now first, because I'm still like debugging stuff, I'm outputting which row and which pin has been set, has been read out. So this is sending it out to the 0. This is not necessary for the key itself. This here is the main part where stuff happens. In case that the key has just now been pressed down for the first time, it has never been read as down before, meaning that the variable key down for this position is still equal to 0. In that case, I will send a keyboard stroke, which is keyboard.write, and here I'm getting the character that I defined in the variable up on the top, and then sending that character for this position. But if I already have this key pressed down, and this already happened, but it's still being pressed down for the second time, then I will just not do anything in here, but just go one up in the variable key down for this key. But there are some other things that are happening. Now, I'm gonna go over this one first instead of this because it's kind of reversed, makes more sense. If the key has been pressed down and has been held down for the number of times that I specified that it has been held down before it starts spamming, meaning that the key down variable, which increases by 1 every time that the key is read out, is higher than my long press delay, then I'm activating the key long variable. And that is basically saying, hey, the user is wanting to write more than just one character, so go into that. And then if this variable is set to true for the specified key, this is the one it goes into. So I'm checking here if first if this variable is true, and then also if like the enumeration is higher than the spam speed. Even when I'm spamming, I don't want to send a keystroke every single time it's read out, because that's still too many times. What works for my code is about every 15th time. So since I'm continuing to count this up, I'm going in here. If it's higher than the spam speed, I'm sending another keyboard character and setting that this variable again to 1, and then it's going to count up again to 15, then go into here again. And that is how I'm handling the different like key sending. This is not necessarily the most elegant solution, but it works quite well, and it is fairly simple to understand, and you can like customize a lot and get it working exactly how you want. This here is just a function for resetting the key, which basically sets just the variable of counting how many times it has been read out to 0 and setting the key long variable to false. Down here I just have the stuff for the encoder, which is not really important. This kind of code is going to be applicable to pretty much any keyboard project. Now, you're probably going to have to like write your loop slightly different. If you have more rows or more columns, that's going to be different. Or if you want to send MIDI inputs instead of a keyboard, then you're going to change up the keyboard.write and instead send a MIDI signal. But this general structure should give you a great starting point for what you can do for your project. I'm also going to make this code here available. Now, just keep in mind that this is very specific for my use case, but I'll I might like make a slightly more general version of the code that you're gonna have to customize, but that gives you a great starting point for your own keyboard project. So I hope you guys were able to take something from this video and understand a bit better of how to do this. If you have any other questions, make sure to leave a comment down below. I'm very grateful for all your feedback. Also, if you liked the video, please leave a like down below. Make sure to subscribe for more videos like this one and other fun projects. So that's been it. Thank you for watching, and until next time.